Hello everyone, I'm Xiao Gang. Okay, before we continue talking about ASAC, let me first demonstrate several operations that can block the main thread. You might say, I'm already using multi-threading, so why is the main thread still being blocked? It's simple, because you're using threads from the TaskGraph. If you kill the entire thread pool, you break the entire Unreal Engine mechanism, and of course the main thread gets blocked. Because the engine has a lot of physics or audio rendering, it heavily uses these threads in TaskGraph. The engine also uses things like a sync task. So if you compete with the engine for resources, then you are causing trouble. So blocking the engine is very normal. Now let me show you several common ways that block the engine. For example, let's block the engine using the first method, block engine. We call it block thread port, creating our thread pool. Okay, here in this place, the first method is the most common one. Okay, then we write a for loop for 8. For example, let's loop 100 times, 7 times, then we pull it out redirectly. This NE3 might actually be the main thread, but that's not certain. It just means whichever thread is idle. But generally, it's probably not the main thread, right? Then we'll use it here. Just use him. Let's do something bad. Yes, this is the situation. It's within the female lead. There's not a single person. It's your leader. Or your person in charge. Not really familiar with this film company's excellent multi-county mechanism. When they are relatively unfamiliar, this situation will occur. That is, sometimes we need to download hundreds of tasks, and we have a lot of data. When we need to read and write concurrently at the same time, then, if you write code like that, congratulations, you successfully injected the ready-made one. Let's inject for 2 seconds. Made 100 of these tasks for us. Then let's test it directly now. Let's see if it injects. These are still relatively simple. The most troublesome is the chain of events situation. That is, I must log in successfully first, then download this image, then read the save file. Only then can I proceed. And in the middle, reading this. Downloading this image might take 20 or 30. Then reading the save file. There might be several places that need reading and writing. Also need to modify. Also need to verify. Also need to decrypt these things. Then these things all need to be done with multi-threading, because if you do everything on the main thread, you will need 100 seconds. If you use multi-threading, then you split it into 10 threads. It might only take 10 seconds to complete, but they have some dependencies on each other. These dependencies can also be handled. Then we will explain how to handle this issue shortly. Also right here. Then we delete this. We move this one to the very bottom. We use it. Okay, here we are. When we press 1, we will fire the main shot. See, my computer screen is completely frozen now. It won't move at all. So if I do 100 of these tasks, each one will block for 2 seconds, conservatively, okay? It will probably block for about several tens of seconds. Yeah, because at the thread level, it should be, specifically, it doesn't have many threads. You need to take a look. It might have several dozen threads. Then you just let it run through one round. Once there are free threads, that's it. Actually, at this point, how do we verify if it is really blocked? That's very simple. We do a check. We let it print something. Let's print this. It seems we can try to get this frame rate. Let's see if we can get the current text. The engine can get it. Because inside the engine, there is a global variable called form. But I'm not sure if it is exposed to C++. If it is not exposed to C++, so let's just ignore it, because we will use that tick later. It's about the frame count of the global tick, because after the engine starts, it will advance frame by frame. Okay, here we'll have it print this float. When we start, you'll see it keeps refreshing. After I execute 1, you'll see it gets stuck, right? It can't move at all. Then you have to wait about a few tens of seconds, and only then does it continue moving. So it's roughly like this. Then we'll show you other ways that can also block the thread. Things that often block the thread. Actually, if you use this, using this will also cause lag. Let's demonstrate the second way to block the thread. Okay, here we just need to use this pull refer. What is pull refer? We haven't covered it yet. But it's also a method that blocks the thread. Alright, paste it over, and organize it. Okay, here we set it to 100. Okay, this parafile we haven't covered yet. We'll explain it later. We'll cover it later. We just need to demonstrate that this will block the video memory. Let's check. This might need to include a header file. This index is needed. We can print this index. Hey, wait, let me check. Hey, where does this go? Let's print this index. Because the previous parameter is looping 100 times, each loop sleeps for 2 seconds. Then this will, let's execute it. This method will also block the existing process. Then we execute the second one. Okay, we'll directly modify this part. Book. Okay. You'll find it's stuck now, right? And it completely blocks the main thread. Then, based on the time we just mentioned, you might have to wait 10 to 20 seconds. This method will also block the thread. You can see it has finished executing here, right? Like 100 tasks, right? Executed by para4. Unity has para4, but Unity's para4 is different from UI's para4. Don't apply it directly. Absolutely do not apply it directly. Then some friends might ask, won't this block the thread? That is, you are now doing this task on the main thread. So if I do it through another thread, will it block the thread? For example, if I do this like this, because we know this method will block the thread, we do it this way. Will this block the thread? It will also block the thread, as we explained to him. Because this thing of yours is used to throw tasks in TaskGraph, it executes the task group every frame, then moves on to the next frame, doing it this way. So in this way, you actually will also block the thread. We don't need to test it. It will still block the thread. So the current requirement is that I might really have dozens of tasks. These dozens of tasks have nothing to do with the engine. I also don't recommend redoing a set of thread pools. That is, I don't want to rewrite a set of thread pools. For example, I write the small function and put 5 threads inside it. Then these 5 threads, I'll hang it up. Then I'll expose another interface. Then I can pass tasks. Then these 5, whether passing 500 tasks or 5,000 tasks, these 5 threads will execute them individually. It has nothing to do with the engine, although they all consume hardware resources. But I don't want to write this thread word. I don't even want to write this. Verbal. Is there a way to solve this? Of course there is a way to solve it. So these are some classic thread blocking methods. Then we'll cover them in the next lesson. That is to say, I don't want to write runnable either. I also don't want to write thread-related terms, but I still need to declare many threads. So I want to use it all at once. Is that possible? Yes, it is. See you in the next episode. Thank you, everyone.